everyone, and thank you for having me here. It's super exciting to be in this people of like-minded, not many in Australia. So what I wanted to talk about today is one of the analysis projects that we've done on a recent comparative study of online probability and non-probability panels. And usually when there have been many of those studies, and usually the focus of those analysis is on sampling mechanisms and representation differences and causes for bias. What I want to focus today is more on a measurement error and how we can improve potentially the bias by reducing measurement error. Here we go. Excellent. Before I talk about the project, just would like to acknowledge my co-authors, in particular Sam Slamovich, who did a lot of the analysis for this project, but also Darren, Andrew, Michael and Ben, as well as a broader Social Research Center team who worked on the comparative study. Okay. So I probably don't have to explain to the audience here why we care about careless respondents. I do want to just emphasize a few points from Ward and Mead paper, a review on careless responding. And while it's just one of a suite of measurement error types within the total survey area frameworks, we particularly worry about those respondents because of their potential impact on estimates, potential reduced reliability of a range of measures, including psychometric measures, as well as introduction of spurious correlations as a result of random errors and impact on statistical power. So before I talk about the analysis, quick overview of the definitions. There's many terms and ways of defining careless respondents. For the purpose of the study, we've adopted Ward and Mead framework, and they define careless responding as participants who are not basing their response on the item content. And it occurs when the respondent doesn't read an item, doesn't understand an item, or is not motivated to think about it. There are many related terms, and satisficing is probably the term that you would normally hear in the context of survey methods. But I did want to emphasize that it's different from bogus or other intentional fraud type responding, and also different from social desirability bias. In the context of Ward and Mead framework, they introduced 3 dimensions for measurement of careless respondents, and I think most of you will be familiar with these types of measures because they're pretty much standard data quality measures. And they group them into invariability, fast response, and inconsistency. And they also talk about different measures for causes, which are different but consistent with other frameworks by Krosnick and Tarango, who talk about task difficulties, ability, motivation, as well as response model involving cognitive processes of comprehension, retrieval, judgment, and reporting. So let's move on to the study. I don't have time to talk about detail of the comparative study, but I've got QR codes here, so you can have a look and look on the papers documenting both studies and information about our online probability panel life in Australia. The couple of points to mention here is that the study was 8 arms altogether. I'm only focusing on 5 in this presentation, which is 4 different opt-in panels and our online probability panel. And the other point to mention that all samples from all the panels were administered the questionnaire at the same time and in the same mode. And the only other point to mention is that the questionnaire was specifically designed to be able to measure bias by comparing to a range of external benchmarks. For the purpose of the study, we had 2 main questions. One was whether prevalence of careless respondents was higher in non-probability panels, and panels and in the online probability panel. And the second one was, does it make a difference? So yes, maybe the prevalence is higher, but the literature hasn't been quite mixed about whether that matters when it comes to the quality of estimates. In terms of the metrics, the way we operationalize the Careless respondent metrics, you can see here using the 3 dimensions. So we use straight lining, midpoint selection, and first response for invariability dimension. For fast response, we use speeding. What's important to note here is that for speeding definition, we use the combined data set. So if you're looking for speeding respondents in non-prob only, you'd be identifying different respondents because they're generally faster compared to when you include probability respondents. For inconsistency, we had logical checks where we looked at implausible combinations of respondents for items in the questionnaire, and there were not items that were specifically included for that purpose. There were items that were substantive items but had implausible combinations. And also a couple of statistical inconsistency measures looking at the outliers and the distance from response to from one response to the rest of the data set. And those statistical measures, again, used the full data set combined. For the composite metrics, we used very simple definitions. We simply flagged respondents where they had at least one metric triggered on any of those metrics, 2 or 3, and also separate invariability and inconsistency flags that were defined where at least one in each class of those metrics was flagged. For the purpose of bias assessment, we used standard, comparative study approach of distance from benchmark using Duncan index, and you can see on the slide a range of items that we had available benchmarks for that included a range of primary, secondary, demographic, socioeconomic, behavioral items as well. So just very quickly, some results. I guess you can see from the slide very clearly that for every metric, non-probability panels have a lot more careless responding prevalence than a probability online panel. And to clarify here, what we are looking with, that's not raw non-probability data. That's the non-probability data that went through the hygiene cleanings that the opt-in line panels already do. So they're clean respondents that would normally be included into the estimates and data sets. So, and using the metrics, you can see they're still much more prevalent in the opt-in panel for all except one metric here. And when it comes to the composite measures, so it's the third from the left, right, where you have at least one flag, you can see that if we were to exclude all of those cases that triggered at least one of the careless respondent metrics, we'd be excluding up to 15% of non-probability samples and potentially up to 5% of the online panel. So the question next is, does it matter? Like, okay, so we've got all of those careless respondents, but what does it mean in terms of our estimates? So where you can see here is if we exclude those careless respondents for each of the individual metrics, it makes no difference in terms of bias assessment for the probability online panel. For the non-probability panel, it's a little bit mixed, but generally the bias reduces, especially when you look at the logical checks, which is interesting because it's the least frequent used data quality measure and also mostly requires more work because it's questionnaire specific and needs to be thought about at the design stage. And when we look at the composite measures and what happens with the bias as we exclude more of the respondents, what's quite dramatic here is that by reducing all of those 15% of careless respondents from the online panels, the bias closes the gap between probability and non-probability closes and becomes almost non-existent without any other adjustment, weighting, or measure. So that was an unexpected finding. And just to summarize, as I said, careless responding is much more prevalent in non-probability panels, and removing careless respondents from non-probability panels closes the gap, but it does not impact on the bias of the online probability panel. There are obviously some limitations of the study, one of which is we only had 4 panels and 1 probability panel. So we're looking forward to some of you in this audience replicating this research and seeing whether these findings hold in other contexts. Thank you.